is an important exam question, sorry, about conservation laws and also about quark compositions. Yeah, all right. So show that the collision obeys three conservation laws in addition to energy and momentum. So how I remember the conservation laws is remembering CBSL, but you need to be a little careful because strangeness is not always conserved. Especially in weak interactions, it's not conserved. Only on strong interactions, strangeness is conserved. So let's make a little note of that. So a lot of the times you don't even need to show that strangeness is conserved. So we're going to focus on showing the other three variables, charge, baryon number, and lepton number, are conserved in this interaction. We're going to make our own little table. And we're going to write the reaction that's happening on top of it on one complete row. So neutron plus positive pion, or positive pi meson. So let's show the charges on both sides are the same to start with. So the charge of a K0 meson is just 0 because it's neutral. The charge of a proton is 1. So the total charge on the left is 1. The charge of a neutron is 0, but the charge of a positive pi meson is 1. So we've shown that charge is conserved. Let's move on to baryon number. Only baryons have a baryon number of 1, and antibaryons have a baryon number of -1. Because the K0 meson is not a type of baryon, it has a baryon number of 0. A proton has a baryon number of 1. A neutron has a baryon number of 1. A pi0 meson, again, is not a baryon, so it's a baryon number of 0. Leptons examples are electrons, neutrinos, and also muons. Those are the three you need to know. In this example, K0 meson is not a lepton, so it has a lepton number of 0. A proton is not a lepton, it has a lepton number of 0. A neutron is not a lepton, so it has a lepton number of 0. And a pi plus meson is, again, not a lepton, so lepton number of 0. We've shown that the three variables of charge, baryon number, and lepton number are conserved, so this collision is possible. Now let's move on to quark compositions. So with quark compositions, I put sort of 4 little things you should always think about in each question. So first of all, this K0 meson, is it a baryon or a meson? Yep, it's a meson. So that means that it's going to have a quark and an anti-quark pair. Let's write this out. What is the charge on it? The charge is 0. What is the baryon number? Well, because it's not a baryon, there's a baryon number of 0. What is the strangeness? You have to be a little careful here because if it does have a strangeness, it will tell you in the question. In this case, it tells you that it has strangeness of 1. Now when you think of a quark and anti-quark pair, that when you combine it, it has a charge of 0, a baryon number of 0, and a strangeness of 1. Straight away, just a reminder by the way, an anti-quark would have the exact opposite variables. So an anti-strange quark would have a charge of +1 over 3e. It'd have a baryon number of -1/3 and a strangeness of +1. So if we know it has a strangeness of 1, that automatically means that there has to be an anti-strange quark, because that's the only way a strangeness of 1 comes out. From there, because an anti-strange quark has a charge of +1 over 3e, and we want a charge of 0, we then combine it with a down quark, because that would then make it so that when you combine them, the total charge is 0, and then the baryon number would be -1 over 3e plus 1 over 3, so it would be 0. So it would be an anti-strange and down quark. Moving on to the next one, again we're going to use this template. Is a baryon or a meson? It's a meson, so this has, I'm just going to rub this out so we have space for this next one. That is a positive charge, by the way. Sorry if it's too small for you to see, but because it is a meson, it has a quark and anti-quark pair. The charge is equal to 1 because it has a positive charge. Baryon number is 0 because it's not a baryon. And the strangeness is 0 because it hasn't told us anything about the strangeness. So we always assume it's 0. So what quark and antiquark pair gives us these 3 combos? In this case, it'll be the up and anti-down quark. How I came to that conclusion was an anti-down quark has a charge of plus 1 over 3e, minus 1 over 3 baryon number and 0 strangeness. These combine to give a strangeness of 0. The baryon numbers add to give 0, and the charge would then add to give plus, well, 2 over 3e plus 1 over 3e is 1e. So it gives a charge of 1. Lastly, a proton. So let's run it out again. Hopefully this template helps with sort of dealing with quark compositions. Just taking off these 4 variables. So a proton, is it a baryon or a meson? It's a baryon, meaning it's made up of 3 quarks. What is the charge of a proton? It's 1. The baryon number of a proton is 1 because it is a baryon, and the strangeness is 0 because it hasn't told us anything in the question about the strangeness. So what 3 quarks combine to give a charge of 1, a baryon number of 1, and a strangeness of 0? So if we think about it, we know a strange quark is not involved because otherwise that would affect the strangeness. To get a charge of 1e, you have to do 2 over 3e plus 2 over 3e minus 1 over 3e, meaning it's 2 up quarks and 2 down quarks. Sorry, 2 up quarks and 1 down quark. Also, 2 up quarks and 1 down quark would add to give a baryon number plus 1 as well, which satisfies this criteria. And that's the end of this question. Hopefully that made sense, and if you have any questions, please just let me know. Thanks for watching.